and the molecule approach the surface, the downward cohesive force on it increases because the number of molecule in the upper half of the sphere decreases. Now when we see the molecule C, we are going to see the molecule C. The molecule is C is just on the free surface of the liquid. It's half of the sphere of the influence is in the air and half of the sphere of the influence is in the liquid. Like 50% that molecule is deep in the liquid and 50% it is above the liquid, or we can say it is present in the air. So the upper half of the sphere of influence contained very few molecules of the air. So the downward force on the molecule become maximum. This applies to all other molecule on the surface of the liquid. This intensive or cohesive pressure which is present on that molecule. So if the molecule move from the interior of the liquid is brought to the surface, then work want to dip that molecule inside the liquid, then certain amount of work has to be done on that molecule against the downward cohesive force, because there is a downward force which is trying to bring it down. So to bring it down, we have to put some work against that force, and the potential energy will be increases. If potential energy is increases, this shows that the molecule of the surface possess greater potential energy than the inside the liquid. In nature, a system tends to have minimum potential energy for stability. At equilibrium, hence the liquid surface is trying to have the least potential energy, which tends to maintain least surface area. So that this tendency of the free surface of a liquid at rest to have the minimum area, minimum surface area is called its surface tension. There are many factors which affect the surface tension of the liquid, like temperature. If we increase or decrease the temperature from the room temperature, then the surface tension also increases, because if we increases the temperature, then the force of attraction will be decreased, because the molecule will become mobile, and if we decreases the temperature, then molecule will come closer and attraction will increases. So the temperature factor affects solute concentration, attack the amount of solute particle we are dissolving, intermolecular forces between the two layers of the liquid, and the hydrogen bonding, because as we are taking water, so the molecules of water are binded together or held together with the bonding which is known as hydrogen bonding. Phenomena which are observed due to surface tension. So the excess pressure in a soap bubble, we see the soap bubble forms. So the excess pressure in the soap bubble, formation of spherical droplets, capillarity, weighting and not weighting property of certain liquids. Now the method of the measurement which we are going to use to measure the surface tension is drop analysis method. And in this drop analysis method, we have to use an instrument or a glassware which is known as stalagmometer. This method was first time described by Tata in 1864, who formed an equation which is now called as Tata's law, that is work is equal to 2 pi r by, where W is the drop weight, R is the capillary radius, and Y is the surface tension of the liquid. Capillary is a fine tube which is present inside the stalagmometer, which is going to pull the liquid towards itself. So further, this is stalagmometer. What the work of the stalagmometer? Surface tension give a definite shape to a drop of a liquid. More is the surface tension, larger is the dropper side. This is the principle of stalagmometer. So if we take a liquid of a more surface tension, then the surface tension will be more, and if we take the liquid of a less surface tension, then the size of the liquid will be small. The stalagmometer is an apparatus with a bulb and a capillary. Liquid is filled in the bulb and allowed to flow through the capillary in front of the drops. In the surface tension is high, larger drop is produced and a number of drops are less for a given volume. Thus, more is the number of drop, lesser is the surface tension. So, ability of a liquid to flow in a narrow space without the assistance of its opposite force or external force like gravity Capillary action is something called capillarity and capillary motion. Basically, whole phenomena of surface tension is based on this capillarity only, because the liquid, we are going to check the ability of the liquid which flows against the external force like gravity, which pulls the liquid down. These are the following apparatus which we are going to use in a practical, like beaker, stalagmometer, stopwatch, density bottle. Now, the formula which we are going to use here is gamma is 2 upon, because this practical is going to be done in reference to the water, and water is considered as a liquid, it is considered as a universal solvent. So, its surface tension and its density is fixed. Here, gamma 1 and gamma 2 are the surface tensions, eta 1 and eta 2 will be the drops of the water, and d1 and d2 are the density. Now, I am going to tell you how we are going to calculate the density. What is density? Density is mass upon the volume. Now, we come to the procedure of the practical, that is how to determine the densities of water of a given liquid. Here the unload liquid we have taken is alcohol, that is ethanol. So, first of all we have to clean the density bottle, then we will weight the empty density bottle, then we will fill water with the distilled water and then weight it, and then we will weight that density bottle with the experimental liquid, that is ethanol, and after taking all the weights we are going to calculate the density. Okay. Then after we have calculated the density, we are going to calculate the surface tension, and to calculate the surface tension, first of all we are going to wash our stalagmometer with chromic acid solution, then distilled water, and then we will fill that stalagmometer first with the water and then with the ethanol, and we will, there is a bulb present like it is showing in the diagram, that we are going to fill the liquid till the mark A, and we are going to, that is a capillary mark A, we are going to fill that liquid with the mark A, and then we will adjust the position of the stalagmometer and we will allow the liquid to flow down, and we will adjust the stalagmometer like that it should deliver 50 to 20 drops per minute, that is 3 to 4 drops in 15 seconds. Then we will start that count and we will allow the liquid to flow from mark A to mark B, and this we are going to repeat 3 times as we have to take the mean of the liquid. So, this is the table for which on which we are going to calculate the density of the liquid. Like first of all we should know at what room temperature you are going to work, then weight of the empty bottle, that will be W1, weight of the density bottle, that will be W2, weight of the empty bottle, that is W1, weight of the density bottle W2, which will be with the water, and weight 3 will be the weight of the density bottle and a given liquid, and then we are going to calculate the density with the formula, that is d1 is equal to W2 minus W1 upon V. V is the volume of density water which is always fixed, that is the volume of the liquid is 25 ml. Basically, density bottle is also known as pycnometer. In market, it is considered as a pycnometer. And second will be the density of the ethanol, that will be W3 minus W1 upon V. So, by this formula, we are going to calculate the density of the liquid. Now, this is the table to determine the surface tension of the liquid. We are going to take 3 readings. 3 readings are taken because we have to take the mean, because every time there will be the fluctuation in reading, so we have to take the mean of the reading. To take the mean of the reading, we are going to sum all the 3 reading and then we are going to divide it by 3. So, we are going to get the mean for the water also and mean for the ethanol also, and then we were going to put all the values in the formula, that is gamma 2 upon gamma 1 is equal to N1 D2 upon N2 D1, where gamma 1 and gamma 2 are the surface tension of water and ethanol respectively, N1 and N2 are the number of drops of ethanol, water and ethanol, and D1 and D2 are the densities of the water and ethanol. Here, as we are taking water as a standard, so the surface tension and the number of the drops of water are fixed, and surface tension get varied at the room temperature. So, if we variate the temperature, the densities and the number of drops are going to get changed. So there will be, every time there will be change in the value of surface tension. So we cannot say that it is 100% calculation of surface tension. We will say it is a relative surface tension, because temperature parameter always get varied. So we are going to calculate relative surface tension of a given liquid with reference to water, and the unit at which we are going to calculate it, it's dyne per centimeter. Now what are the application of surface tension? So lubricating oil spread easily on all parts because of their low surface tension. If we increase the surface tension of the oil, it is not going to spread on the parts. Then cotton dresses are prefer in summer because cotton dresses has fine pores which act on a capillary action for the sweat. So at the cotton dresses also there is a phenomenon of surface tension. Dirt that removed from the detergent are added while washing clothes because of the surface tension of water is reduced. So near about in each and every phenomena surface tension is used. Thank you. Now after demonstration we are going to move to see the practical, or we are going to perform the practical.